Okay, hopefully by now you've watched my original video about which ram pump design is the best. That was back in March of 2021, and hopefully you watched my mea culpa, which was where I backpedaled on all that in the summer of 2022, because in 2021 I did not consider pump pressure. All I considered was how much water was squirting out of the delivery pipe with 3 foot of head and 12 foot of elevation. So now we're going to make a series of just erratic clips of different types of check valves and see what kind of pressure we get out of it. And I'll be the first to admit the pressure tank I'm using is just something I threw together with an apple juice jug I got from Walmart. And the reason I'm using that as opposed to something I know is proven to be most effective is because I want to see how much water is in that pressure tank when I'm changing the check valves. So, okay, let's get started. Today I want to take a quick look at some check valves that you would probably be using on a residential ram pump. This is the kind that comes with a linear ram pump. It's a PVC check valve. It doesn't take very much pressure to crack this valve, and this would go between your intake valve and your pressure tank. Basically what it does is that it allows water to flow through here, but because it has a spring and a little diaphragm in there, that prevents water from flowing backwards. And you can get these in different sizes. Well, both of these that we're looking at here are 3/4 inch diameter as far as the size pipe they would fit, but they have different cracking pressures. So when you buy one, you'll have to just check into that. The other type of check valve, and the ones I use, are called swing check valves. I'm showing 2 here. I've got a brass one and a stainless steel. And even though they're both 3/4 inch diameter, in other words, they would fit a threaded pipe 3/4 inches wide, the weight on these things greatly different. This stainless steel has a very heavy swing valve in there. So if you have a lot of head, in other words, from your water source to your pump is pretty high, you know, maybe 8 or 10 feet, this may be something you might want to use as an intake valve. But if you've got 3 feet or less of head, the only way you're going to get the stainless steel valve to work is if you tilt it 45 degrees. And even then, you got your fingers crossed that it will work. These brass check valves, just about anyone you'd buy off of Amazon or at your Home Depot, Lowe's, home supply type stores, they will work for both an intake as well as a no return valve between the intake and the pressure tank. The third type I want to look at today is a check valve it's a spring-loaded check valve. In other words, it doesn't just have a flap that would open and close. There's a diaphragm in there that actually slides open or close with a spring on it. So it takes some pressure to make this work. You can use this. You would not want to use this as your intake valve unless you remove that spring, because it would just take too much water pressure to open it. This particular valve here has a crack pressure of 5 pounds. And this particular one is not very expensive. I think it's $11 or $12 on Amazon. I don't see any way to adjust the tension on that, but I tested it, and the crack valve on this is right at 5 psi. So this you would use between your intake valve and your pressure tank. in a future video when I show you some hacks and tips, some modifications. If you're from your round pump, you're trying to pump downhill, this could be a good little tool to use on your delivery pipe as far as faking some back pressure onto the round pump system. Putting this on your outlet that would go to your delivery line if you're not pumping uphill. If you're pumping level or downhill, this would fake about 10 or 11 feet of height. It can fake that back pressure for you, but we'll do that in a different video. All the tests I'm going to do today will use this homemade pressure tank. This is nothing but an apple juice jug I bought from Walmart. And the reason I'm using that is because I can actually see the water inside the tank, and that gives me an idea of how the pressure is reacting with the tank. This is not a very efficient tank, but if you want to make one, it's really easy. Go buy you a bottle of apple juice and get you one of these adapters. This is a slip to threaded 3/4 inch adapter, just a coupler. You can get this at just about any home improvement store. And it seems to fit almost perfectly into the mouth of this apple juice bottle. And then with a 3/4 inch male NPT on the other side of it, that could screw right on into your check valve or your T, your threaded T or whatever. So this is what we're going to be using today. Not a very good thing to use for tests, but since I'm using it for all these check valves, we'll be able to make a comparison. So I think it'll be a valid test. This is the setup I used back in March of 2021 when I tested the best round pump design. And the reason I decided to do it like this was this pretty much replicates the situation I have in my creek. From the tip of this tape to the spool of this tape is right at 36 inches. And as you can see, I'm using less than 36 inches of water total to do my test. This is less than 2 foot from here to the ground, and then I'll have less than a foot of water, well, right at a foot of water in there, for a total of what I'm calling about 3 feet of head pressure. So that would be close to 2 feet of actual elevated height, which would affect the angle of my 20-foot drive pipe. And then that 1 foot of hydrostatic pressure, it really does make a difference. Water has a pressure rating of 0.43 pounds per square inch per foot of elevation. So just by adding a foot of water into my supply tank, that's giving me almost a half a pound of back pressure right there. So testing this way is a lot different than having your intake only an inch deep in a shallow creek. So keep that in mind when you do your test in your backyard. Here's an oddball. We're going to test the pressure. I don't have any hoses hooked up to it. Just like all the other tests I'm going to do today, we're just mostly interested in how much pressure can these things build up depending on the design. Here I have 20 foot of drive pipe, 3/4 inch, 3 feet ahead, and here we've got what I've been calling the vertical style. In other words, my waste valves are at the end of the end of the pump, the back end of the pump. But instead of having one 3/4 inch waste valve, I've got 2 1/2 inch waste valves. And for this check valve going up to the pressure tank, it is a swing type check valve. However, it's stainless steel. Okay, I've got 2 pressure gauges on here. This is the kind you can buy from Amazon or Home Depot, Lowe's home improvement store, that just screws onto a hose type fitting. This one here is called a This is called a pull pump pressure gauge, and what I like about it is it goes from 0 to 60 as opposed from 0 to 200. I got a feeling this gauge is going to be much easier to observe for relatively low pressures. Okay, let's turn it on and see if we can get it started. Let's open up the drive pipe. Wow, looks like I've got a lot of dirt in my thing here. Let me get these check valves cleaned up. I haven't tried using them since the big flood last week. I had a very difficult time getting this double half-inch waste valve deal going, but now that I've got it leaned over about 45 degrees, it seems like it's doing okay. So that sort of tells me that if I'm going to use a double waste valve, I probably need a steeper slope than what I have here. Let's take a look at the pressure. Looks like she's up around 10 psi. Oh, it quit. I'm barely getting any kind of pressure in this tank with this double waste valve deal, and I'm using the swing check valve going to the pressure tank. We're going to change that check valve and put a spring-loaded check valve in there and see if that makes a difference in the pressure. Now, sitting there around 5. But in the clear water pressure tank, you can see we've got the water about halfway, maybe a third of the way up the tank, and it quit. As you can see, I've removed the pressure tank and the outlet valves from this pump. I'll be using the same pressure tank, pressure gauges, and delivery valve on all my tests today. Right now, the only change I'm going to make to this pump, I'm going to replace the stainless steel swing type check valve with a spring type check valve. Okay, we have this double check valve deal finally started up. Checking the pressure. It's been going about 10 or 15 seconds and it's not even up to 5 psi. I'll come back in a minute and we'll look at it. Well, it's been about a minute and a half and it looks like we're up to about 7 psi. To be honest, I really thought that if I replaced that swing check valve with a spring type check valve, that this would give me the same high readings that I would get from a linear ram pump. So this is the vertical ram pump with a spring type check valve. And so far not so great, but it's slowly but surely building up. I'm going to let it go for a while and see if we can get the pressure built up a little more. Now that she's been cycling for a little bit, I might try straightening up these valves. I have them angled at about a 45-degree angle. And in another video coming up, I'll be checking different types of check valves, and I think I'll experiment with the supply tank and see if increasing or decreasing the angle of the drive pipe makes any kind of difference with your pressure. Well, just while I was sitting there chit-chatting, this thing's up to almost 10, right at 10.
Let's compare that to one of these standard gauges you can buy. See how hard it is to read that thing? To me, the only advantage to this type of gauge is that it comes ready to go. You can just screw it right onto your garden hose fitting. This particular one, this is the pool pump pressure gauge. Comes with a 1/4 inch shaft on it, a male NPT thread shaft. But you can buy one of these adapters to go from 1/4 inch to a 1/2 inch, and then just get you a regular 3/4 inch T that has a 1/2 inch opening on the top. But anyhow, if you go to Lowe's, Home Depot, someplace like that, Ace Hardware, those guys should be able to explain to you what the deal is. Whoops, looks like we stopped. Almost looks like I got trash in the line. Hold the phone. Yeah, I had a little bit of trash in one of those check valves, and they both stopped. So I went ahead and cleaned it out and straightened it up a little bit. It's still angled maybe 5 or 10 degrees, but nothing like it was a while ago. And almost immediately, this pressure is up to about 12. Came up pretty quick. We're going to just keep an eye on this for another couple of minutes, see what happens. We're getting right there at 15 psi, and you can see that the pressure tank is more than halfway full of water. As I've mentioned in other clips, water has weight. Well, not more than just weight. It has pressure depending on the elevation. So if I had a delivery line on here and I had like 15 pounds of pressure, mathematically that means that I could probably pump to an elevation of 30 feet. That's just mathematically. I don't know how well they'd be coming out of the end of it, but you know, if water has a PSI of 0.43 per vertical foot, you know, you can just do the math there and come up with that sort of thing. What we're trying to show here is that, hey, depending on the pressure in the tank, would you want something that has low pressure in the tank or something that has high pressure? Well, that depends on the elevation of your storage pond. You know, how high is the end of that delivery pipe? So I think we can safely say this is going to go at least up to 15 psi. I'm going to try and straighten out those check valves just a little bit more and see what happens. I have the dual 1/2 inch check valves on a 3/4 inch ram pump. The check valves are now pretty much exactly vertical, and the cadence has slowed down just a little bit, but it seems like a really good cadence right there, and they are hitting hard. But it looks like we have maxed out with this system at 15 psi, and it may be like that regardless of what kind of ram pump I test, just based on the fact that I've got 3 feet ahead over there. Okay, let's try reassembling this ram pump, and we'll do another test. Oh, this is pretty interesting. When I've been checking the pressure down at the pump, I've got all the delivery valves shut off, and it seems like all I can get is about 10 psi. I'm not a hydrologist, but I have read that water has pressure of about 433 pounds per square inch per foot of elevation. So just to sort of understand the concept easier, let's say that for each foot of elevation, excuse me, for each foot of elevation on your delivery, it's going to produce, let's just say, a half pound of PSI. That being assumed, if we have like 10 PSI down here, and we know that it's going to, back pressure is going to be up, you know, a little less than a half pound per elevated foot, we can guess that, hey, this system right here could possibly pump up to 20 foot elevation. It's really going to be a little more than 20 foot, but 20 foot, you would still get something out of it. So what I'm going to do on these tests, if I get something other than 10 PSI, I'm just going to double the PSI and say, hey, that's how high this setup will work. That's how high it would pump. If I get 5 PSI with everything shut, I would say the best this pump setup is going to do is 5 PSI. That means I'm only going to be able to pump an elevation height of 10 feet. You understand what I'm saying? If I could get 20 PSI, which I know Land to House does, if you watch his YouTube channel, he frequently gets 20 PSI, then with whatever he's got, he could probably pump up to 40 foot high. All right, we're going to check a different style of pump. We're going to change that spring check valve and replace it with a swing type check valve and see if we can get any kind of pressure out of a setup like that. This is very similar to what I just tested. It's a linear style ram pump. This has dual half-inch valves on it, even though I'm using a 3/4 inch ram pump. I've got these two half-inch, which I can tell you right now is using more water than a single 3/4 inch waste valve. I can tell by just watching my fill tank over there. I have a shut-off valve on it, a float valve, and it's taken so much water out that the float valve is not shut off yet in the past 10 minutes. The only difference I'm doing here is that instead of a PVC spring-loaded check valve, I've got a brass spring-loaded check valve. And maybe I just got the connections, the nipples a little tighter than I did before, but the pressure seems better than anything I've tried today. About 13 pounds of pressure. That's the best we've had so far today. So, let me take this thing loose. I might do a quick check just to see what kind of water is being delivered, but that's not the purpose of my video today. Today I'm just trying to compare check valves, you know, spring versus swing. Okay, we are back to the vertical round pump design. This is the geometric shape that I use more than anything. Water comes in the dry pipe but goes out the waste valve at the rear, and then in the middle you would have another check valve going up to the pressure tank. Now what I've done different here is that instead of another swing valve, I've got a spring-loaded check valve there, a brass spring-loaded check valve. And let's go over here and check the pressure. This thing's been popping for about 4 or 5 minutes. And as you can see, my pressure is up over 15 psi. That's the most I've gotten out of anything today. So this pretty much proves, in my mind, the idea that it's not the shape of the pump that makes the big difference. It's whether or not you have a spring-loaded check valve going up to your pressure tank. Okay, I'm going to let this run a little while longer, see if I can get it up to 20 psi. And in the future we'll make a video where we can test this as far as how many gallons per hour I'm getting out of it. Today it's all about pressure. And so my next clip should be the vertical ram pump, but instead of using a spring-loaded check valve, I'm going to do like I did in the very beginning, just put another swing valve in there, facing upside down from the waste valve. And if we don't get any pressure off of that, that will explain why that design is good for low back pressure, and the one with the spring-loaded check valve would be better suited if you have, you know, a high elevation delivery. So, okay, let's check this out here in a minute. If you build a 3/4 inch ram pump, I know a lot of plans have you reducing your delivery down to a 1/2 inch diameter. I don't believe that's necessary, as long as you use like one of these Y splitters. Go to a hardware store and look at one and look inside of it. The where the ball valve is, that's less than a 1/2 inch. It's probably 5/16 inch or something like that. Maybe 7/16 on some of them, but I don't think you have to worry about reducing things. Just get you one of those adapters to go from 3/4 inch NPT thread to 3/4 inch garden hose thread, and put one of these splitters on there. It's pretty handy to have that anyhow. And you can adjust, you know, your pressure with these on-off valves here on the Y splitter. Here's a curious finding, although it's not totally unexpected. On the ram pumps where I have a spring-loaded check valve, where I'm getting, you know, 10, 15 psi, I have trouble pumping it 4 foot high. Two foot, 4 foot, it just will not pump. If I go up to 6 foot, the one I'm using now won't pump. Now I'm up to 8 feet and I'm still having trouble with it. It's like it's got too much pressure, it wants to be up higher. I can keep this pump going between 4 and 6 foot elevation, but I have to turn my release valve, just have it partially open to keep the back pressure up, and I don't get very much out of my hose. That greatly reduces the output when I restrict that that valve. All right, I'm going to take this pressure valve off of here and just put a swing one on and see how it does at these elevations. Vertical style ram pump with 2 check valves that have flaps in them. 2 swing type check valves. Pressure just a little less than 10. I've been running it about 15 minutes now. I cannot quite get to 10. I don't know what this tells me. Actually, I thought that I would only be getting like 6 psi on this, because in my experience that I could get a lot of water out of here, I just couldn't go very high with it. don't know, I'm going to have to think about this. This is not the results I expected. Okay, what I've discovered today is that even with a swing type check valve, 2 swing type check valves, you can still get pretty close to 10 psi pressure. It just takes a long time to get there. But by moving that hose up and down that ladder, I find that most of them require 6 feet, 6 to 8 feet of back pressure to run. However, this thing here with the 2 swing check valves will run at a total of 4 foot high. But I'm not getting as much out of it, which shocks me. Yeah, I don't know what I found out today. But at least we know that you can get pressure in any kind of valve. You get it a lot quicker with the spring type valve. So I would say if you're going to pump uphill a pretty good distance, go ahead and build you a pump that has a spring type check valve in it, whether it's designed laterally or vertically. I think that would make a difference as far as pumping high. If you have very low elevation, say you've only got 10, 12 feet of height, and you got 3 feet or less of head, I would say build a pump like this. It's so simple, and it starts easy. I don't understand why it starts so easy. I think because it doesn't have a spring-loaded check valve, you don't have to keep pushing the waste valve up and down to prime the pressure tank. I think just the weight of the water flowing through the drive pipe puts some water up in that pressure tank. Gives you a head start on getting the thing going. I think I might just shut everything down, give it a rest for a day, come out here tomorrow. We'll talk about this a little bit more. I might make a separate video. But anyhow, I want to do an update just to let you know that even though I prefer this kind of pump, it may not be best for everybody. If you've got a lot of elevation, even if you build one like this, you can go ahead and just replace one of the check valves with one that's got a spring in it. And vice versa, if you bought a linear pump and it just won't do because you don't need much elevation, you can replace that spring check valve with a situation like this. 2 flappy ones. Alright, we'll talk about this some more in a different video. What I've discerned from all this is that the style of pump, the geometric design of the pump, was not quite as important as the check valve going to the pressure tank. And I tried 3 different kinds. Flat valve kind, the swing check valve. That's stainless steel, but you could use brass. Here's a PVC check valve, very similar to the ones that come on the linear ram pump sold by Land to House. And I'll put a link in my caption about Land to House. Very good site to go to learn about ram pumps. Actually, I was able to build up pressure a lot faster using this check valve as compared to the swing check valve. And it didn't matter whether I had it going horizontally or vertically. Both ways gave me a quick rise in pressure on my pressure tank. This is also a spring-loaded check valve. It's a brass one though. In other words, it works just like this, except it's made out of brass, and I think you really get a good seal with this thing. And of all my tests, I was able to get my highest pressure using this particular valve, and this can also be used horizontally as well as vertically. So I think the check valve going to your pressure tank is probably the key thing in getting more pressure. For me, having more pressure is not what I'm looking for in my particular situation. I don't have very much elevation between my pump and my reservoir. So for me, I'm going to go to a brass check valve that just has the swing flap in it, and that's what I'll be using for my setup, because I've got about maybe 3 feet of head, and I'm only going 10 to 12 feet of elevation over a long stretch, maybe 750 feet. So for me, that means that I want the vertical style pump with a swing check valve. For you, you know, if you're going more than 12-foot elevation, you might want to seriously consider a spring type check valve in your system somewhere, just to make sure you can, you know, you're able to pump up higher.